So first, let's talk a little bit about the atom. Atoms are basically the smallest unit of matter, the most fundamental unit of matter that still has the properties of the matter that we see, such as gold is something that you're familiar with. It's sort of shiny. It's gold-like. It conducts electricity very well, conducts heat very well. An atom of gold would be the smallest amount of gold that still has those properties, or the smallest amount of matter you divide a gold up that still has the properties of gold. Atoms, though, can be broken down into further parts. And as you can sort of see at the bottom, we have a table of the three types of fundamental particles that make up the atom. And those are the proton, the neutron, and the electron. Now, the proton and the neutron both have a location in the nucleus. And so in this case, in our drawing right here, the nucleus is at the very center of the atom, right in there. If we zoomed in, we could zoom in all the way. This particular picture is of a helium atom. It's a helium-4 atom. And so you can sort of see they've zoomed in and they've got the picture of the helium nucleus right about there. And as you can sort of see, the unit on here, I don't know, it may be difficult for you to see here, but it says it's 1 femtometer right there. So that gives you basically an idea of the size of that nucleus compared with, say, the larger atom, which is at 100,000 femtometers. So for the one that goes all the way from this side all the way to here. So that just gives you an idea of the size of the nucleus compared with the overall size there. So it's a little, I mean, it's somewhere in the neighborhood of in this case probably about between 1/100,000th and 1/150,000th the size of the overall atom. Now the electrons, on the other hand, are located in what's called the electron cloud, and that's the part that sort of sits out all around on the outside here. We'll talk about the electron cloud and what it means a little bit more once we get to our unit on electrons. But for right now, all it is, suffice it to say that the electrons they exist in the electron cloud. It's not a cloud in the sense that we normally think of clouds. They don't do orbits in the way that you may have seen sort of the standard third grade model of the atom. They don't sort of orbit around like planets, but they do exist in the electron cloud. For our protons are one of the two larger of the three particles. They have a mass of about 1 AMU, 1 atomic mass unit. In fact, actually, they have a mass of exactly 1 atomic mass unit for a proton. Atomic mass unit is usually just defined as the mass of a proton. So that's how we'd know they have exactly that. So for the most part, that's a very, very small unit. You would need 6.022 times 10 to the 23rd protons to make just 1 gram. So very, very small unit, but that's the mass of a proton. Neutrons are just a tiny bit smaller, but they're so very close to the mass of a proton, we consider them to be roughly 1 AMU as well. So protons and neutrons have the same mass. Electrons are much smaller, 1,836th of an AMU for the mass of an electron. So as they're moving around the electron cloud is that they are much, much smaller. And so what we'll find later is that to find the mass of any atom, you add up the protons and the neutrons. You really don't add up the electrons because the electrons are so small we can pretty much ignore them. Now, charge-wise, protons have a positive charge. That should be a positive sign there. Protons have a positive charge, while neutrons are neutral, no charge to them. Electrons are negative. And so this is something that's going to be easy. You're going to need to make sure you remember here. Some of these are fairly easy. Protons are positive. Why? Because they're pro. Pro would mean positive here. Neutrons are easy because they are neutral right there. And then you sort of just have to remember that that electrons are negative. Maybe you could say something like it's a negative experience if you get shocked with electricity, something like that. But just remember, protons are positive, neutrons are neutral, and electrons are negative. Just to give you a little bit of a better idea of the size of the atom, let's suppose that if the nucleus were the size of a marble, here's a marble right here, one I'll have in class. If that were right there, the size of the nucleus, then the overall atom size for a hydrogen atom would be larger than the city of Van Meter. Substantially larger. I don't know, you really can't see this very well, but school is right there. And the interstate exit is right up here, and here's F90 going across there. And so you can sort of see there's the main part of Van Meter, just sort of right up in there. So you can see that if that marble that we saw right before were the nucleus, then the overall size of the atom is absolutely massive, just in terms of, well, just large in comparison. What this basically says is the nuclei are extremely, extremely small. So that just sort of gives you an idea of the size of the nucleus compared with the atom.